Well, good afternoon, everybody, and welcome to this webinar masterclass. So we're doing webinar 2 of our ongoing series of ensuring the accurate classification of variants in BRCA1, BRCA2, and HRR gene variants. Next slide, please. Just a few important housekeeping duties first of all for me. So please can you make sure that your microphone is muted. We don't want to obviously interrupt the flow of the speakers with any background noise. For note, this webinar is being recorded, so if any of your colleagues are unable to access it just now, we will hopefully make it available sometime in the next month or so, once it's gone through compliance checks with AstraZeneca and Merck. And of course, we'll let you know when that's taken place. They'll then be available on our websites as well, GenQA and EMQN websites for you to download and watch at your leisure. An important part of these webinars is the educational component. Really, it's about your feedback and you asking your questions to the panelists. So to do that, we would please ask you to use the Q&A function, not the chat, but the Q&A function, which would appear at the bottom of your menu bar for Zoom, to submit your questions, which we'll then hopefully get around to answering at least some of them during the Q&A session at the end of the webinar. An important point, please, when you are submitting your Q&A function, questions, is to make sure you define which variant you're applying that question to. So please state variant 1 question, etc. So we can obviously triage the data and ask the relevant questions to the relevant presenters. Okay, next slide, please. So feedback is also really important for us. So we do listen to everything you say. We've taken into account a lot of the previous feedback. It helps us make sure that these training sessions are really valuable and educational for you and for your colleagues as well. So after this presentation, you will get an email asking you to complete a short survey, which we'll then use to help facilitate our feedback and ensure that following webinars meet your requirements. Should only take about 2 minutes to complete, but it's really important, please, if you do that we get your responses. Next slide, please. So we've got a fantastic day lined up, or webinar lined up. We've got 3 fantastic speakers. So Trudi McDevitt from Dublin in Ireland, Arjen Mensenkamp from Nijmegen in the Netherlands, and Andrew Muranyi from Alberta in Canada. Thank you very much indeed, guys, for your commitment to this project. We're looking forward to hearing your presentations today. And lined up with me, your chair is my co-chair, and by far the more professional of the 2 of us, Professor Sandi Deans from GenQA. So between me and Sandi, we'll be moderating the Q&A sessions and doing a little bit of the introduction either side of the panelists. So without any further ado, I'll hand over to my colleague Sandi to take us forward on the next section.
Thank you very much, Simon, for a very kind introduction. So if we just move through the slides now, please. Thank you. Just a disclaimer here for all of us presenting today. And then next slide. So just to put this webinar in context, we're now delivering run 8 of the GTAC Variant Classifications Assessment. And today we're going to give an overview of our participation. It has just closed, so we're just starting to review the data. We have our expert panel who's going to give you a bit of background of the variants and how they have come to their classifications and what evidence has been used. And then obviously we will follow up with the EQA summary report from this run that you can then look at in more detail, and we'll have a lot more discussion for you for your education and learning going forward. So next slide, please. Just to put it in context, this variant assessment is an individual-based assessment. It's not laboratory-based. We have other EQAs that assess the laboratory's standard of variant assessment. This is very much for an individual, and it's about competency assessing, so you are able to demonstrate that you can accurately assess the pathogenicity of sequence variants. So it's delivered through the Genomics Training Assessment and Competency tool known as GTACT. And the idea here is you can go onto your online account, you can use access different tasks, scenarios, of which the variant assessment is one of them. And these are constantly reviewed. We do S&Vs, CNVs and other elements as well. So please do take a look. And it works really well for these particular variant EQAs. So next slide, please. So this is a snapshot of the data that we've had a look at for the first time for the assessment of Run 8. So it was delivered during the month of June. We had 534 individuals register. And as we see with other previous runs that this sometimes drops and the number of the participants was actually 400. And this is covered by individuals based in 54 different countries. So it's really nice to see the global spread of participation, and I think that just identifies how poignant and important pathogenicity classification is across all areas of genomic medicine now. So as I say, we had a wide number of countries being representative, and the graph at the top here just gives a summary of those countries whereby we have more than 10 registrants. So we do have lower numbers in other countries, but it's nice to see that we are consistently getting high representation across all of the continents. One of the other things that's very important to look at is the classification guidelines that are being used. So this is a snapshot of what was used in Run 8. You can see here that the majority are still predominantly using the CMG 2015 guidelines alone as a standalone document and point of reference. However, we do see that predominantly the UK-based participants are also using a combination of these guidelines plus the ACGS guidance, which is a UK-based guidance document. We're also seeing a proportion of individuals then moving on to also include the CanVig UK guidance. And then we always have a smattering of those who are using other guidance documents or a combination of multiple different resources. So next slide, please. What's really interesting as well with the EQA participation is you can actually start looking at trends and seeing and monitor and identify any changes. It's really nice to look back on Run 7 compared to the data for this run. And you can see here that the main change is that as an increase in the use of ACGS guidelines along with ACMG. So we've seen an increase of those have reduced because more people are now using the CanVig UK guidelines. So we see an increase from 18% up to 28%. So I think it's raising the awareness through these educational webinars and the guidance webinar that we produced earlier in this year and last year, that people are becoming more aware of more resources and guidance that they can use and adapt, particularly for the HRR genes and BRCA1 and BRCA2. So I think it's really good evidence that people are changing their practice and hopefully learning from that. So next slide, please. Over the last few years, well, from 2017, you can see here that we have consistently had good levels of participation for all of the EQA runs. We have looked at expanding into the HRR genes and Run 7 really was just focused on HRR, but the feedback we're getting from the participants and yourselves is very much due to just mimic clinical practice. You don't know what's coming in the door. You don't know which genes are going to have the variants in them. So they much prefer to have that range of BRCA1 and 2 plus also the HRR gene variants included. Hence the change of format for 2022, whereby we've had all of the genes included in both runs. So next slide, please. This is a summary, and I guess for the first time you can see the expected classification of the variants that were included in Run 8. And you can see here that we have focused both on the ends of the spectrum. So we have pathogenic class 5 BRCA1 variant and 2 class 1 variants. So we'd be looking for very clear definitions of those pathogenicities for those 3 variants. And then also we know that to determine whether a variant is a class 3 or it can be moved up due to evidence basis to a 4 or a a 2, then we've put in 3 challenging variants in there that come out at class 3. So our expert panels are going to describe what evidence they've used and the challenges of moving them out of the class 3 variant classification. So next slide, please. We have great news. We can see here again, using trending data analysis across the EQAs, that we're seeing a real improvement in the accuracy and the sort of the consistency of variant classification. We have now in this run 13% of individuals who are classifying all 6 variants in line with the expert panel and expected classification, and also see a real shift into more variants being correctly classified. So I think this is a real good example of how continued participation in EQA and also educational webinars actually can really benefit genomic medicine and the patient service that we do provide to everyone through the global labs. So I will stop talking about general stats and data now and hand over to the expert panel. Arjen, I think I'm coming to you to kick us off with the first variant, which is an ATM variant. So over to you now, please. Thank you.
Thank you, Sandy. I'm Arjen Mensenkamp. I'm a clinical laboratory geneticist in Nijmegen, the Netherlands. And I would like to discuss the first variant on the list, indeed a variant in ATM. Next slide, please. It's a missense variant, asparagine 814 to glutamine. It's a missense variant, glutamate, I'm sorry. It's a missense variant, and outside the known functional domains, at least outside the known clinical relevance domains. Next slide, please. And it is mentioned in ClinVar many times, 17 times, most of them with the benign classification. LOVD, it has been mentioned as benign and likely benign. It is present in NOMAD, and we chose here the non-cancer female version 211 database, and where it is present in 0.02% in all individuals, and specifically 2.4% in the African Americans. It also contains 8 homozygotes for this variant. The REVEL prediction score, a prediction that includes many other prediction tools, and so it accommodates the more classical prediction tools, comes on a score of 0.34, which is higher than 0.249, the level of a benign variant. The SIFT polyphen didn't agree, and Align GVGD came up with the C0, so towards benign. Next slide, please. So our classification was as follows. There was no evidence favoring pathogenicity, and we had evidence favoring benign. As we have a BA1, the official category is allele frequency over 5% in control cohorts, but that is the general rule, also applicable for recessive disease. For a dominant disease, in which we now here view this variant, we have a 0.19% in NOMAD in total, but in the African American non-cancer cohort is almost 2.5% heterozygosity, which is far over the limit of 0.5% as given for ATM. I will come back to that later. In addition, but of course, BA1 is a standalone criterion already, so that will make it enough to make it class 1. But BP2 can also be considered, and as this has been observed in trans homozygous in presumably healthy individuals in the NOMAD database. It has a slightly lower power if it is in a database according to at least to the CanFQ-K rules and to the ATM rules, but it can be even applied with strong evidence. But again, it's not necessary as BA1 is sufficient. Next slide, please. You, our participants, agree with the class 1 classification for the majority, but still almost 100 participants chose class 2, likely benign. Of course, both will have a similar outcome in the reporting. So next slide, I would like to give some explanations. There is always some debate what kind of data set you can use for classifying for BA1. The African population is the size of the tested samples is quite big and is normally large enough to make classification like this. But 2.5% in that population is over 0.5, and that is specified in the variant creation expert panel for ATM. It's a ClinGen effort for expert panel on ATM breast cancer variation, and the rules from the VSAP has been replaced by the CanVic UK. It replaced their own rules, so we will continue with the ATM specific rules as the standard for ATM. They apply to 0.5% as a cutoff for BA1. So BS1 is not applicable as the frequency is over 0.5%. The BS2 is an observed in a healthy adult individual, is not applicable for breast cancer for ATM as the penetrance is reduced, so you can only use that for high penetrance variants. BP4 is also a good one, but if you follow REVEL, and that is written in the VSAP ATM classification as the sole source of classifications, the score is 0.34, which is too high to call it BP4. BP6, what has been used by some of you, so that is expert opinion, is by using a ClinGen rule is discontinued. Next slide, please. And I will hand over now to the next presenter, and that is Trudi.
Thank you, Arjen. So I'm going to just bring you through two BRCA1 variants that are at opposite ends of the pathogenicity spectrum, but with very similar categories of evidence applied for their classification. So next slide, please. So the first variant is a missense variant in BRCA1. The prior risk of pathogenicity is therefore unknown, and it's a clinically significant residue in the BRCT domain, methionine 1775. So next slide, please. It's reported as pathogenic widely. There are 7 submissions on ClinVar since 2018, when the ACMG guidelines would have been applied, and it includes Enigma, which gives it a pathogenic score. So it has a 3-star rating on ClinVar. It's pathogenic on LOVD, on BRCA exchange with the Enigma data. On NOMAD, on the NOMAD non-cancer females data set, it's present in 1 individual in greater than 50,000 individuals. So that's a frequency of 0.0019%. The REVEL score for this variant is 0.728, and other in silico tools also support pathogenicity. So next slide, please. So we didn't report any evidence favouring benignity, and the evidence that we agreed to be applied for pathogenicity are as indicated in this table. So starting with BS3 at a strong level, this is functional evidence, and we based it on 2 functional studies that have been validated using the BNIC assessment, validated for use with PS3 at a strong level. So that's Findlay et al. And Bowman et al. So we could apply PS3 strong to this variant. We also use PP1 strong. Now this is based on the multifactorial analysis by Enigma, and we use the latest CanVic guidelines that allow you to convert multifactorial data likelihood ratio scores to ACMG evidence points, which means that you can more appropriately use data that maybe would previously have given you a BP5 supporting. You can now give it the weighting it deserves, really. So we the multifactorial data for segregation gives, it has a likelihood ratio for odds of causality at 229. So this converts to 7.42 ACMG evidence points, which gives you a strong for pathogenicity for segregation. We also applied PP3 based on the REVEL score of 0.2728, and also PM2 supporting given the one individual in greater than 50,000, which reaches the threshold for PM2 use of less than 0.002 in a control cohort of greater than 50,000. So with 2 strong and 2 supporting, we've already got class 5. So next slide, please. Other evidence which we agreed could be applied is PS4 at a supporting level, whereby the variant prevalence in affected individuals is increased compared to controls. There are 5 cases on the UK database, but the ethnicity of the cases isn't available. So you couldn't perform case control analysis because you need to use matched, ethnically matched controls. There are 19 breast cancer families in the Rebecca et al. Publication of nearly 30,000 families, and also the fact that PM2 is applicable. All this evidence allows you to use PS4 at a supporting level on a case counting basis. We also agreed that PM5 at a supporting level could be used. This is where there's another missense variant out there that's in the same position and widely reported as pathogenic. So in this case, variant BRCA1 5324T to A rather than T to G is reported as pathogenic. So this is methionine at 1775 changed to lysine. There are a couple of caveats with using PM5 supporting. The first one being that the Revel score of the variant, your variant and the variant you're comparing it to need to be such that your variant has a higher Revel score or is stronger for the in silico tools. In this case, the 2 Revel scores were almost identical. So therefore we downgraded it to use it as supporting. The other caveat is that if the variant you are comparing it to is only pathogenic or likely pathogenic because you're using functional studies, then you can't use PM5 and PS3 for your own variant. So in this case, the variant we're comparing it to reaches at least class 4 without using the functional evidence that's available for it. So we can use PM5 at a supporting level, and we can also use PS3. So all of that gives a comfortable class 3 pathogenic score. So next slide, please. So you can see that about 92% of participants reported a class 5 and a small number class 4. So the clinical actionability of the outcomes is the same, so that's really good. We did notice though in the class 3 participants that there were a significant number that actually classified the variant as class 5, but when you look at the evidence, there wasn't quite enough to get it to class 5 and there should have been a class 4. And also for some of the class 5s, only class 5 was entered without accompanying evidence, probably potentially based on the Enigma classification. So next slide, please. So looking at it in a bit more detail, about approximately 90% returned class 5 using the evidence that's listed there. We found that it was hard to tell the difference actually between those reporting class 5 and class 4, because the similar evidence was used, but just at different levels, so that those using class 4 didn't quite get to level 5 based on the strengths that they'd applied. But we'll probably, I'll cover that in a bit more detail in the report. So class 4, fewer participants used strong, including the use of PP1 at a strong level. PM5, most participants actually applied this at a moderate level, but as explained earlier, the Revel scores are virtually the same, so we need to downgrade it to a supporting level. PP5, so this has a similar theme now to the next variant I'm going to discuss. So different strengths were submitted for PP5. It's important to note that if you are using PP5 based on reports from a reputable source, so ClinVar submissions since 2018, including Enigma, you can only use PP5 at a supporting level. And if you are extracting the data from Enigma to use according to the individual components for the multifactorial data, then you can use you can then apply it at a stronger level, which is what we did using PP1 at strong. But you need to be careful that if you're doing this, you don't also use PP5, because then you're using the same evidence more than once. PS4, there was a range of strengths applied for this, but only supporting applies in this case. PM1, it does impact a clinically significant residue in BRCT, in the BRCT domain, but PM1 cannot be used with PS3, according to the combinations that are laid out in the latest CANVIG guidelines. The PM2 and PP3 different strengths were also applied to these, but only supporting applies. So next slide, please. So classification of variant 3, next slide 3, please. So this variant was at the opposite end of the spectrum. It's an in-frame deletion, and the prior risk of pathogenicity is unknown. Next slide, please. Multiple reports on ClinVar of benignity since 2018, and a 3-star rating because Enigma also classified it as benign. On LOVD, there's a mix of classifications. BRCA exchange, which is the Enigma data, it's classified as benign. On NOMAD, there are 6 individuals in the cohort of greater than 50,000 on the non-cancer females database, so giving a frequency of 0.0112%, which is higher than is allowed for PM2. In silico prediction tools, there's for splicing, there's no predicted impact on splicing. So next slide, please. So there was no evidence favouring pathogenicity, and for benignity, we applied BP6 at a strong level, similar to the previous variants, by extracting the multifactorial data from the Enigma submission in Parsons et al. So doing that and using the table in the latest CANVIG guidelines, you can get a strong for benignity. And we also applied BS3 strong based on validated functional studies that allow you to use BS3 at a strong level, Bowman et al. 2020. So already we've got a class 1 benign because we've got 2 strong pieces of evidence. Additional evidence that we did discuss as a group, there's an error here, so my apologies, this should be BP3 supporting, not strong. So sorry about that. But we did discuss and agree that it could be used for an in-frame deletion in a region that's is not well conserved. So we agreed that BP3 at a supporting level could also be used. Next slide, please. So the summary of the classifications, the expected was class 1, but most participants returned a class 2, and a small number also class 3. But for the class 1 and 2, the clinical actionability outcome is the same again, so that's good as well. We noticed again that some of the class 2 participants actually should have been a class 3 because they used evidence for benignity and pathogenicity. And some of the class 1s should have been a class 2 because they only had 1 strong piece of evidence. So next slide, please. So for class 1, you needed 2 strong pieces of evidence. In this case, we applied BS3 and BP6 as strong. So the difference between the 2 is really that those in class 2, in most cases, didn't apply a second strong piece of evidence to get them into class 1. So again, I'll go into that in a bit more detail in the report. BP6, this is really similar to the PP5 previously, that if you are using it based on reputable source, so that's the ClinVar submissions plus including the Enigma, BP6 supporting only can be applied. And if you're extracting the multifactorial data, you can use BP6 strong. But again, you need to be careful that you're not using BP6 supporting with the individual components for the multifactorial analysis pulled out of it, because it's using the same evidence twice. BS1 and PM2 were applied by significant numbers of participants, but these don't apply in this case. In the case of PM2, there are too many cases on NOMAD for PM2 to be applied. And in the case of BS1, there aren't enough cases on NOMAD to be able to apply this. If you look at the CardioDB tool, the maximum tolerated allele count for the variant in the NOMAD population that you're looking at is actually 15 females, and we've got 6 females. So neither of these lines of evidence for population data can be applied. PM4 was actually applied by a significant number of participants, and you can see why this might have been applied. It's for an in-frame deletion of a single amino acid at a supporting level. However, you need to be cognizant of the conservation of the amino acid. It needs to be a highly conserved amino acid for PM4 to be applied. And this amino acid at position 369, if you apply the conserve tool, you get 5, and the range is 1 for low conservation and 9 for high. So it's moderately conserved at best, so it wouldn't be appropriate to apply PM4. In addition, applying it at a low supporting level is minor in the background of the very, very strong evidence for benignity for this variant. BP4 was applied also by significant numbers. Now, we didn't apply this because BP4, the in silico tools are designed for missense variants and the effect on protein function. Potentially, participants might have applied it based on the no impact on splicing that was maybe used for BP3, but this variant had a low prior probability of having an effect on splicing to start with, and BP4 for in-frame deletions is not really covered in the guidelines currently. There will be some guidance from the Enigma group for BP4 use for in-frame, small in-frame deletions in the near future, but at the moment we agreed not, we didn't use BP4. So next slide, please. So now I'll hand you over to Andrew for variant 4.
Thank you, Trudy. Next slide, please. All right, so variant 4 is a BRCA2 variant. It's a missense variant at nucleotide 202. It's an 80G. The prior risk of pathogenicity is unknown, and it's not in a functional domain. Next slide, please. So this variant is in ClinVar. It's a 2-star rating, 2 submissions. It's also an LOVD. It's not present in the NOMAD non-cancer group. It's got a Revel score of 0.101. SIFT and polyphen are contradicting, and aligned GDGD suggests towards benignity, as with mutation tasting. Next slide, please. So evidence for favoring pathogenicity include PM2 supporting. This is if you are using the ACMG guidelines. Evidence towards favoring this variant being benign is BP4 supporting. So the Revel score of 0.101 would qualify, as also 3 out of 4 in silico prediction tools also estimate this to be tolerated. And it's in a poorly conserved amino acid. So according to ACMG guidelines, you would have a PM2 supporting and a BP4 supporting, which would give you a class 3 or a variant of uncertain significance. Next slide, please. So this is where it gets a little interesting. If you're using the CanVig UK guidelines, you use the evidence slightly differently for this. So being absent from NOMAD would qualify for a PM2 moderate. You would also have the BP4 supporting because of the Revel score. But using guidance from the BRCA1 and 2 specific CanVig UK guidelines, you can also use BP1 supporting, as it's not in the DVD domain of the gene. You still arrive at a class 3, a variant of uncertain significance, but you do have different evidence or slightly modified evidence to get you to this point. Next slide, please. So the majority of participants classified this as expected as a variant of uncertain significance. However, there were a few that classified this as likely benign and likely pathogenic. only one is likely pathogenic. The reason for the individuals classifying this as likely benign weren't always completely, so not all the evidence that was used to arrive at this classification was clicked off. It seems it could be because they used the two benign pieces of evidence, but didn't use the rare or absent from population databases. Unfortunately, I wasn't able to see which guidelines these individuals were specifically following, but I suppose it's possible if they were using the CanVig UK guidelines and did not use the evidence that this variant was rare, that could be how they arrived at the likely benign, as that seems to be the evidence that was used. Next slide, please. Oh, now I'll bring you back to Arjen, our first speaker.
Yes, I will continue with the PELB2 variant. So next slide, please. This concerns a missense variant in PELB2, tryptophan 912 to glycine. It is present in the WD40 repeat, which is known for its interaction with BRCA2 and RED51, amongst others. Next slide, please. For this variant, we checked the databases. It is not present in ClinVar at the moment. It is present in LOVD, but without classification. The variant is not present in NOMAD, and the REVEL score is 0.56. CYFT and polyphen are both deleterious, and aligned GVGD is C65, which is also deleterious. So it is a very highly suspicious variant on the basis of these resources. Next slide, please. There is no evidence favoring that there's a benign variant. We came up with 3 applicable criteria for pathogenicity. The first one is PS3 moderate, a well-established in vivo or in vitro functional study. And for that, we used the Boden study published in 2019, which showed a 90 to 95% reduction in homologous recombination and sensitivity to PARP inhibitors compared to truncating variants. We assessed this assay by the previously mentioned Burnage method and applied it at a moderate level. I will come back to that later. As the variant is not present in NOMAD, you can apply PM2 supporting according to the ACMG criteria, and but if applying the CanVig UK guidelines, you can apply it at a moderate level. The next is the PP3, which is also a difficult one for here. Multiple in silico tools, as the one I just mentioned, predict a deleterious effect, but not all. I will come back to that in the next slides. So using these 3 criteria, we came up with a DOS classification +3. Next slide, please. As you can see, the majority of participants agreed with that classification, but a large group of people came up with a likely pathogenic classification, most likely due to a different use of the PS3 classification. Next slide, please. And I will come back to that now for this assay. Like I said, the variant is tested in the Boden paper as a deleterious variant. And then the next question is how to use this variant, how to use this knowledge in variant classification. Well, for that, we used the Burnage paper to weight this assay. And according to this paper, you first have to ask the question, does this test fulfill disease mechanism? Well, the question is yes. It is testing loss of function, and it is testing homologous recombination, which is assuming to be the proper functional output. And the next obvious question is, does the test take basic controls into account? Does it use at least 2 replicates? Does it include positive and negative controls? It does. And then if you really want to calculate the odds of being pathogenic, you also need to take into account the number of controls that have been incorporated. And in the Burnage paper, there's a very nice Excel sheet available, which you can use for that. And they've used in this paper 20 controls, from which 12 were pathogenic truncating variants, and combining that with the functional outcome, and it was completely fulfilling so the 12 pathogenic variants came out with a deleterious effect, and the 8 benign variants came up with a functionally normal outcome. You can calculate the odds of pathogenicity, which is 8 for being pathogenic and not 8 for being benign. Next slide, and next slide. That gives odds of pathogenicity of 8, and if you then convert that to an evidence strength equivalent, based on several papers also by Teftigian et al., a number of 8 odds of pathogenicity applies to be high in the PS3 moderate range. So therefore, we applied this assay at a moderate strength. Next slide. So we applied this for the in this masterclass. However, we know that the expert panel for PELB2 from Klingen will likely not support any functional test at all, as virtually no pathogenic missense variants are known at this moment. So the assay was validated using truncating variants, but you would of course also like that some pathogenic missense variants are taken into account. The same is that for now there are no missense variants known that are pathogenic. It is not possible to validate functional tests at all. So that does not alter the classification of these variants, but it is something that we need to take into account. Therefore, classification of the VUS. Next slide, please. We also applied PP3 supporting using as multiple prediction models suggested a deleterious effect. However, the REFL score is too low for that. CANVIC UK guidelines suggest only to use the REFL score and not a combination of all tools, and therefore, according to the CANVIC UK rules, you cannot apply PP3 support. The other way around, into the benign variant, BP1 can be considered, as well as just I mentioned, missense variants in PELB2 are extremely rare at most, if at all present, and therefore BP1 can be applied, and this is also a recommendation, a specific recommendation in the CANVIC UK guidelines. So these are alternatives that could have been chosen. Next slide, please. And I will hand over back to Trudi. No, not to Trudi, to Andrew.
Yeah.
Thank you. Next slide, please. All right, so the last variant is the RAD51D. It's a frameshift variant. Prior risk of pathogenicity is unknown, and it's in the C-terminus of the ATPase domain. Next slide, please. So the ClinVar has one submission for this variant, classified as being of uncertain significance. It is not present in the NOMAD non-cancer database and is not present in HGMD. Next slide, please. So evidence favoring this variant being benign, we weren't able to find any. Evidence favoring this variant being pathogenic is PVS1 moderate. This is a frameshift in the last exon of the gene, and it disrupts less than 10% of the encoded protein sequence. It's predicted to escape nonsense-mediated decay, and so that arrives at a PVS moderate. And a PM2 supporting as per the ACMG guidelines, as this is absent from the NOMAD database. However, if you're using the CANVIC UK guidelines, once again, this becomes PM2 moderate. So there's a slight difference in the strength of evidence you use here, but it still arrives at a class 3, a variant of uncertain significance. Next slide, please. So the majority of individuals classified this as expected as a variant of uncertain significance. However, there was a significant number of individuals who classified this as pathogenic or likely pathogenic. And the main reason for this is the use of the PVS1. Next slide, please. These individuals used PVS1 at a strength higher than the moderate strength recommended. I just thought I'd quickly take a moment to go over the tie-in publication that goes over the PVS1 decision tree. So we have a non-sensitive frameshift variant, which is in the last exon, so it's not predicted to undergo nonsense-mediated decay. Although this variant is found in a domain, it's not in a critical region of that domain or a highly conserved region of that domain. And there aren't very many, I don't think there are any pathogenic missense variants in that region. So the role of the region in the protein function is unknown. It's a loss of function variant that's not frequent in the general population and is present in a biologically relevant transcript, and less than 10% of the protein is predicted to be removed, which arrives at PBS1 moderate. And this is just a schematic of, it's a review article of the common pathogenic, known pathogenic variants in RAD51D, and you can see at tail end here where our variant is found, there really aren't any recurrent pathogenic variants, so it's unknown if this region is critical for protein function, specifically where this is. The conserved region is way over here, which is a few exons over. And so I think that is the main reason why individuals got to a higher classification than variant of uncertain significance for this variant. Next slide, please.
Thank you, Andrew, very much indeed. And thank you to all three of our expert panel for a very comprehensive review of the 6 variants and a great discussion and information on why they've been classified in that way. So this is just a snapshot of the classifications, looking across the 6 of them in a whole. I just want to flag one error here on the slide that variant 3, the expected classification is actually class 1. So the green and blue are switched around the wrong way, and I believe this may be the case on the report on the GTAC system, so we'll make sure that's corrected urgently so you can download your updated reports. So I think generally looking at this as an overview, we can see that the size of the unexpected classification bubbles are reducing, and that's a reflection of the data that we presented at the top of the webinar, whereby more and more individuals are classifying in line with the expert panel and using the same evidence. So I think, again, just another evidence that we really are all learning at the same time, and that these educational webinars are really worth the while. So I believe there's quite a few questions in the Q&A function now, so please do put your question in if you've not already done so, and as Simon requested, if you could just start by saying which variant your question's related to, so we can actually pick off our expert panel one by one and make sure they're answering the right case for us. So Simon, I'll hand back to you then to start us off.
Yep, thank you very much indeed, Sandy. So you're doing a great job, participants. We've got lots of questions for our panelists. I'm going to actually kick off with a question for, I think it is Trudi for variant 3. So Trudi, for variant 3, what are the differences in the evidence criteria applied for those reporting class 1 and class 2?
So it's to choose class 1, you need 2 strong pieces of evidence. So it simply looks like the same range of evidence has been used by both sets of participants, but those using class 2 just used 1 piece of evidence at a strong level. So that seems to be the main difference. It's just the strength that's used for the variants.
Right, okay, so really that's the main differentiator between those 2 results. Yeah, okay.
Yeah, and I suppose it's just the take home from that is just to look at the strengths that you're applying and make sure they're being applied appropriately. Just check all guidelines for that, because there is a lot of information on the correct strength to use.
Fantastic, thank you. Okay, I've got a question here for Arjen, sorry. So with, I think it's variant, is it variant 4, PALB2, Arjen? 5. What would be needed to classify this variant as likely pathogenic class 4?
Yeah, that's a difficult question. Also because this variant is very rare. So we need to have more families with this variant, and it would be even better if we can do any segregation analyses in these families. And if you also can prove that all these tumors are HR deficient, And perhaps if we have multiple independent functional assays that point in the same direction, we might be able to get to class 4, because if you look at it, your first suggestion is it might be class 4, and that is also some people from the participants chose class 4. But we have to be careful here. We have examples, for example, for CDH1, where a functional assay was completely misinterpreted and missense variants were classified too high on the basis of functional assays. So we should be careful here with applying a functional outcome before knowing that missense variants are pathogenic at all.
I mean, you make an interesting point, a general point there about the lack of evidence for a lot of these variants in these genes. I mean, it seems, obviously there's really well established data for BRCA1 and 2, but as you start to get into more of the HRR genes, there's clearly a lot less evidence, isn't there, on levels of functional effect of all these different variants. So it is becoming much more difficult to actually give a really good classification of the variants.
Yes, and also because of the lower penetrance of these variants, it is hard to get really nice penetrance, as we know from the in the olden days from the BRCA1 and 2 variants that were highly penetrant, very present in families, and that will not happen for, well, especially not for ATM or CHEK2. However, for PALB2, we can assume that HR is the main function of this gene or this protein, and the assays that have been used are really comparable to the assays that have been used for BRCA1 and 2. So one can assume that function is the same, outcome is the same, so probably the pathogenicity will be the same. But we hope to get more evidence for
that. Thank you, Arjen. So Sandi, I've got one more question before I move over, hand back to you. So this is a question for Andrew. So for variant 6, the frame shift occurs in a domain. So why don't you use PVS1 strong?
That's a good question. The frame shift does occur in a domain, but when you look at the conservation of that domain, the key residues, and there's a functional paper to show this, but the key residues are not disrupted by this. So the key residues are upstream of where this frame shift occurs, and there aren't any there are no known pathogenic variants around either upstream or downstream directly near this region. So based on that, it's not quite appropriate to assume, because it's in a domain, that this is functionally relevant where this change is occurring.
Great, thank you, Andrew. Sandi, over to you.
Thank you, Simon. So Trudi, I'm going to come to you. There's quite a few questions here in your 2 BRCA1 variants. Firstly, why didn't you use PM4 for the BRCA1 in-frame deletion? So that was variant 3, that was a class 1.
So a good number of participants actually did use PM4, but it wasn't appropriate to use because it needs to be an in-frame deletion of a residue that's highly conserved, and that wasn't the case for this one. So it wouldn't be appropriate to use PM4.
Okay, thank you for that. Interesting that many participants did use it as well, isn't it?
And you can see why they did, because it's an in-frame deletion of a single amino acid. So
there's quite a few questions coming through about the other BRCA variant, which was variant 2, around the ethnicity and I can't say that word, and about the the population database, etc. So we'll probably cover that in more depth in the QA summary report. But just to sort of summarize, so for that variant, why does the PM2 was applied if there was one individual in the African subpopulation with less than 50,000 alleles?
So according to the CANVIC guidelines, if you're looking at it in a subpopulation, it's greater than 1 in less than 50,000 is my understanding. But we're looking at 1 individual in a total of greater than 50,000. So we thought it was appropriate to apply PM2 at a supporting level.
So I guess it's sort of on that borderline, isn't it? You've got to just be a bit pragmatic and your own expertise, I guess, don't you?
Yeah.
Brilliant. Thank you. So as I say, we'll cover a bit more of that in the report, because I think it's something that people really are seeking guidance on. Thank you. Simon, do you want to come back to you for another few questions?
Yeah, so I'm going to come back to variant 1 actually. So Arjen, so this is, please could you explain again why BA1 is fine to use for variant 1?
Well, the easy answer is that is recommended by the ClinGen ATM variant expert panel, and it is recommended by them to use a 0.5% cutoff. Where you can use a calculator for that. That was just mentioned by Trudi, and if you do that, you assume the frequency of breast cancer compared to the penetrance of ATM, which is about 20%. You can calculate what is the maximum likelihood of a variant, of a pathogenic variant that still can occur given the prevalence of breast cancer. And well, if you use the calculation either dominant or recessive, you will come up at about 0.5% as being the maximum frequency of a pathogenic variant to be able to occur in the general population.
Thank you, Arjen. So I think we've got so many questions. It's fabulous to see it, but it's so hard to triage it as well. So please do excuse me while I'm trying to read and actually assimilate what the questions are as well. But I've got here a question for variant 4, which I think was Andrew, wasn't it? So BP1 are non-conserved residues. Which parameters should I use to determine conservation? Blossom 62, no idea what that is, but I'm sure that's relevant to you. Which is the cutoff for non-conserved residues?
That is a very good question. At the moment, I don't think we have a lot of guidance from ClinGen or Canvig UK specifically for what to set for conservation, at least none that I'm aware of. So I think these parameters would probably be best to be set internally in your lab and just be consistent. In our lab, we're using Alamute, and we're using the threshold of if it's not highly conserved, but I suppose others might have a more stringent recommendation. I think there is in the works a RNA splicing guideline that might be coming out, and I'm hoping that will give us more guidance as to a specific threshold to use for this. That is a very good question, though, and unfortunately, I don't have a concrete answer for you.
Certainly one I think we could perhaps consider for the scheme report if we've got more questions coming in related to that, couldn't we? So it obviously covers an interesting perspective. Looking at variant 5, which I think was Arjen, so will it be possible through PS3 moderate for the would it be possible to do through PS3 moderate for that PALP2 variant? How would you consider a GFP assay and PARP-I sensitivity using cellular proliferation assay?
Well, the Boden paper used both a GFP HR assay, that's the assay that is being used for almost all homologous recombination genes, and the PARP-I inhibitor, but they both more or less use the same outcome, and that's homologous recombination. But even if they were different, you still end up with the question: are missense variants pathogenic at all? And I'm afraid that's the almost philosophical question that we have to answer first before we can move back to the functional assay.
Yep, I think you covered that very well in the earlier question we just raised, didn't we, about that? So I think, Sandi, I'll hand over to you.
Yeah, just a couple of feedback for us, which is really, really helpful. So can we in the future, can we cover maybe guidance on using BP1? As some people are finding it difficult to select BP1 based on the domains. Is there like a general rule? Maybe we can cover that going forward. Also about can we give future guidance when using PVS1 for variants in the last exomes of the HRR genes? I know that's something that's very topical in these particular gene sets, so I think that's something we could focus some educational webinars on, but so I'm going to open. Do any of you want to comment on the use of PVS1 for variants at the end of the coding sequences of these genes? Any sort of top guidance, take home message?
Well, I think yeah, so for the gene specific guidelines, and I think they also mentioned in the UK cancer guidelines, specific amino acids are mentioned which we know that are truncating and give loss of function or associated with cancer. And normally the last one is generally assumed as being positive, and that's below that point you don't know. And of course we know that the last exon is not, NMD will not occur for variants in the last exon or in the last parts of the one but last exon, and you can use that as a guideline as well. And in the general ACMG guidelines, they use the 10% rule as a very general cutoff. But perhaps Trudi has something to add.
I suppose the gene-specific guidelines would also have specific recommendations as well. And there is a really good source of information on the CanVig website that we can probably put a link to in the reports and so on, where there's very nice presentations by James Drummond that does go through this in great detail, which is very helpful.
Absolutely, that's exactly what I was thinking when that popped up. He's a great expert in that field, so good call there, Trudi. So Simon, I'm going to just end on one, which is a general one again, for the recommendation from the panel is, so for all these 6 variants, we've been talking about the Revel in silico prediction tool. Is this recommended tool by the panel? Trudi?
The Revel, use of Revel?
Yes.
Yeah, there is a recommendation now to move towards these meta predictor tools away from the multiple in silico tools, because they're just more accurate. There are some publications out, I haven't got it to hand, but we could perhaps even address that in the report as well, provide a bit of detail on that. But yes, the recommendation is to move towards these and away from the SIFT and polyphen and align GVGD.
That's great, thank you. Andrew, do you agree? We're running out of time, so a quick.
Yeah, I would agree. I think we're in a transition phase. I think some gene-specific recommendations are suggesting other in silico, but in general, I think that the shift is going towards Revel scores.
Great, thank you. Arjen, anything you want to?
Yeah, I know that for BRCA1 and 2 and TP53 base del is being recommended, and basically because it also includes indel variants that can be predicted. And so yeah, Revel is better than the one we previously used, so it is an improvement.
Great, thank you all. So Simon, I'll hand back to you to close the session.
Yep, thank you very much, Sandi, and a big thank you to you, the participants. We've had about 150 of you today dialed in, which is brilliant. We hope you found this educational and helpful to you. Please do make sure you join us for the next run 9, I think it is, later on in the year. A big thank you also to our panelists. Your expert knowledge is unbridled, and it's fantastic to have you involved in this project and in this webinar series. So thank you to you for all the time and commitment you put into that as well. Thank you also to our organisers, MSD and AstraZeneca, and most importantly, thank you to my co-host, Sandi Deans. We wish you a successful and enjoyable rest of the day, and we'll look forward to catching up with you later on in the year. Thanks very much indeed.
Thank you.
Thank you. Bye.